In math so far, we've looked at various models. And the various models we've looked at is we've looked at models that can be linear, which means our data is in a line. We've also looked at quadratic models. And when we look at quadratic models, our data appears to be in a parabola. Now, when we talk about linear models, we talk about the idea of slope, and the line can go up or down. We also know it can go horizontal or vertical. In quadratic models, we know that a parabola can open up and open down, depending on what the leading coefficient is as well. But some data doesn't fit either one of these models. So another kind of model that we're going to look at now is what's known as an exponential model. And an exponential model is when data takes on this shape. The data kind of begins slow, and then all of a sudden it goes up very, very rapidly. We say that this is a model where the data is increasing. Or we can start someplace up above here, and the data goes down pretty fast and then levels off. Here we can see that the data is decreasing. So we can add arrows to these graphs as well if we wanted to. But this is what an exponential model looks like. Now, going back to a linear model, we know that linear models have to have something like y equals x. Or we could have like y equals mx plus b. But there has to be an x to the first. Quadratic models, on the other hand, have to be y equals x to the second power. And we saw that a lot when we factored as y equals ax squared plus bx plus c. What's unique about an exponential model is they're going to take the form of y equals a number to a power of x. This is an exponential model because look at where the variable is. It's in the exponent exponential model. So again, these graphs can take on the shape of something that starts small and gets very large in a hurry, or starts large and gradually goes down and does level off. Now, as we talk about these kinds of models, you're going to hear some new words, and here's one. And one of these new words is called an asymptote. An asymptote is a line that generally is not crossed. It can be, but it's followed. And asymptotes can be lines that are both horizontal or vertical. So if we just took a really quick graph here, and if I put it in these dashed lines, and if I draw a graph in here, these lines are kind of a guide to how to create the graph. These black lines, these black dashed lines, represent asymptotes, horizontal and vertical. And you'll notice in both of these cases that the graph that I've drawn doesn't cross either one. Now, this particular graph isn't linear, it's not quadratic, it's not necessarily exponential, but it does introduce the concept of asymptotes to us. Now, one of the things that you're going to work with as you work with exponential models is you're going to work with equations such as y equals 5 times 3 to the x plus 4 power. Now remember that if we're talking about a function where each x has exactly one y, this can also be written as f of x equals 5 times 3 to the x plus 4 power. And let's say for a moment that we want to find a few values. Let's say we want to find f of 1. Well, what that means is I'm going to put 1 in for x. So if I do that, I'm going to have this 5, and I'm going to have a 3 to the 1 plus 4 power. Now, I can't multiply first. I've got to do order of operations. So I've got to go ahead and figure out my exponent. My exponent is 1 plus 4, which is now 5. So this is 5 times 3 to the 5th power. Well, by order of operations, I need to go ahead and do the exponent first. Now, I had a 1 plus 4 in the exponent, so that quantity had to be done first. So this is going to result in 5 times 3 to the 5th. Well, 3 to the 5th, remember, is 3 times 3 times 3 times 3 times 3. So we've got 9 times 3, 27, times 3 is 81, times 3 again, 243. Now, if I take 5 times 243 here, I'm going to go ahead and get a value of 1,215. So we see f of 1 is a very large number right away. How about if we had something like f of negative 4? Well, this would give us 5 times the quantity, 3 to the negative 4 plus 4 power. Well, this is really 5 times 3 to the 0 power. And if you recall, anything to the 0 power is 1. So 5 times 1 is 5. So we create these ordered pairs, and notice again, we have this, from f of 1 to being 1,215 to f of negative 4 being 5, that's a huge, jump or decrease depending on which way you're going in a very short amount of time. Now that doesn't always happen. It's the nature of the exponential functions. But let's look at one last one. Here's 5 times 3 to the negative 5 plus 4 power. So this is 5, and this is going to be 3. Now that's to the negative 1 power. Now recall, a negative exponent doesn't make anything negative. It just makes it 3 to the negative first becomes 1/3. Flips that 3 to the denominator. So this is 5 times 1/3, and we're going to leave this as a fraction of 5/3. But now between negative 5 and negative 4, there wasn't a huge increase, you could say. So that's what we're going to learn about, the exponential model. And it leads into other models that we can look at as far as data is concerned too.